I'm doing a separate video here on converting into radians simply because I think this is the type of thing that folks will want to be able to um, view separately and brush up on and be able to look at again without having to worry about all the other stuff that they talk about in the book. So radians, again, are just a new way of talking about angles, right? Before, when we had a circle, we said, oh, this circle includes 360 degrees. And circles with degrees, I think, and don't quote me on this, but degrees have been around since like Babylonian times, right? Since like thousands of years BC. And the reason why they use degrees is, or the reason why they just decided, oh, we'll chop this circle into tiny little bits. And the reason why they didn't use, 17 or 211 or something like that is because 360 divides really nicely into tons of different numbers, right? You can divide it by 10 evenly, you can divide it by 12 evenly, you can divide it by 50, not 50, 60 evenly, you can divide it by almost 50 evenly. You can divide it by 5 evenly, you can divide it by 4 evenly, you can divide it by 3 evenly, you can divide it by 8 evenly, 9 evenly. It's great for dividing into these little things. Not sure about 8. Does it divide by 8? Maybe. Yeah, 45. Yeah. Sure. Okay. So it's great for that. However, there are some limitations, and we need mathematicians need a new one, a new unit of relationship. And as it turns out, remember how we had like our circumference formula was 2 times pi times r? We can come up, the mathematicians decided that they needed a new unit that includes pi inherently. And specifically, in this case, 2 times pi. So, as it turns out, there are, instead of 360 degrees, if you were to go all the way around a circle, it would be 2 pi radians. It's a little weird because there's not an even number of radians around a circle. There are 2 pi, so it's 6 point whatever number of radians as you go around the circle. But trust me, this radians end up being much more useful when you get to higher levels of math. So that's why we're going to start learning about them now. The simple way to think of that is I mean, you can read this. They give a good explanation here as well. The conversion between radians and number of degrees, you can think of it as this proportional relationship here. Sorry, let me circle it. So this is the proportional relationship. What they don't do in the book is give a really nice formula in a box that they want you to use. And I highly recommend that you just write this down and circle it 100 times. I'd also make the following modification. So where m is the number of degrees, right? We're pretty used to number of degrees. So I'm going to put m for number of degrees over 360, right? This gives us the portion of the whole, and then we just need to multiply it by the 2 pi, because that's how many radians are in the whole. So we're going to multiply that by 2 pi, and that is equal to number of radians. So I'm going to put RAD just for radians. This is what I would put in a box, and you can come up with some kind of cool label at the top, like rad formula exclamation point, because this is how you figure out something rad, which is radians. M over 360 times 2 pi equals the number of radians. The nice thing about having a good formula like this is that all we need to solve for m, or for radians, is to have a value for m. All we need to solve for m is to have a value for radians. We can switch back and forth. We can just use this as an algebraic formula. And so I'll show you what I mean. The book, let's see, it has an example here. Not my favorite, but that's okay. It says convert each angle measure to radian measure. 180 degrees, they're basically going to take that formula, plug it in. 180 divided by 360 is 1/2. 1/2 times 2 is 1. So therefore it is pi radians. What usually you don't do with radians is multiply out this pi. You just want to leave it in pi, which is again why I had you leave it with the pi earlier. We in general want radians in terms of pi. So it'll either be pi over 2 radians or 2 pi radians or 3 pi over 4 radians or something like that, right? It'll be usually a fraction of pi radians. Again, there's a method to the madness, but do your best to keep pi by itself. Okay, we'll do another example here. To convert a radian measure, so at 60 degrees, we need to convert into radians. Again, we're going to use that. Again, I'd prefer this formula because it has equals radians at the end. We're going to plug it in for m, divide by 360, times 2 times pi. So 60 divided by 360 times 2 times pi. What is 60 divided by 360? Well, this thing reduces down. It gives us 1/6. What is 1/6 times 2? 2/6 or 1/3. 1/3 pi, right? So a simple way to put that is pi over 3 radians. Yeah, that's a nice clean answer. The reason why I want you to you weren't supposed to see that. Yeah. The reason why I wanted you to kind of write out a whole formula like this, as opposed to just kind of a half formula with no equation, is because it's really hard to go the other way if you don't have a nice full equation. So an example here is explain how to find the degree measure of an angle whose radian measure is pi over 4. Well, you could basically try and do everything backwards, but sometimes stuff gets lost in translation. So I like to just write out the formula, plug in your known values, you have a single unknown, solve for the unknown. So again, we'll just go back to this formula. We'll say m over 360 times 2 times pi equals, in this case, the number of radians, so pi over 4. So pi over 4. Now it's just algebra, right? We just need to solve for m. That's our single unknown here, and that gives us the number of degrees. So what's the first step? A lot of people notice that there's pi on both sides of the equation, so we can divide by pi. Boop, gone. What does this pi become? Well, it becomes 1. So just be careful there. It's 1 over 4 equals m over 360 times 2. I would have gotten rid of the times 2 part by dividing both sides by 2. What is 1/4 divided by 2? It's 1/8. And then somebody else pointed out that cross multiplying is a pretty good step. So we can say that 8 times m equals 360, or m equals 360 divided by 8, which is 45, which I wasn't sure if you could do off the top of my head earlier. So that gives us 45. Again, I'm pretty sure that, sorry, I'm going to try to do this so you can see. There you go. Try that. It's to your benefit to make one of these with an equation. So you can switch back and forth between the degrees and the radians pretty easily. Go ahead and try this one out. I'll give you a second before I give you all the answers for it. Pause. Okay. So you should have gotten pi over 2 radians and pi over 4 radians. Again, be prepared to go backwards. And we talked about this one, how there are 2 pi radians in the whole circle. So hopefully that helps you guys with the radian stuff. It's a bit tricky, but again, trust me, radians will make your life much, much easier, even though you haven't been using them your whole life, because degrees are easy for the, second graders to start dividing up and thinking about. Anyway, have a good one.